But it is very simple. You can easily crack these train problems. Okay. It can be categorized as only two: train crossing a stationary object or train crossing a moving object. Fine. So far, what did we study? We studied something about relative speed. So relative speed into time is equal to the distance relative. Right. So this is what we have studied so far. Alright. Fine. And when you talk about trains now, think practically. Don't be like, oh my god, this is the formula, so you have to mug it up. No, never mug up anything. Just think practically. Alright, you're staying in a platform, you're standing in a platform, somebody is calling you and they're asking you, did the train pass you? What do you tell? How do you tell? Right? So you're standing at a particular point, you tell that a train has passed you only if the front of the train has also passed you. Okay, this is not the length of the train, but anyways, this is a train. Alright? Yes? So you're standing here. Fine? You tell the train has crossed you when the start of the train has also passed you, and also the end of the train has also crossed you. That is, you see that crossroad, that goods compartment at the end, right? You see that also. So you see the start, you see the end. That's when you tell, okay, this train has crossed me, right? So that is very important. Fine. So this is when you tell a train has crossed you. Fine. So train crossing a stationary object. It can be subcategorized into two. This stationary object, right, it can have a length or it cannot have a length. So first let's consider the case where it's without length. Without length is basically it can be a hue end, it can be a pole. Why am I telling it without length, right? Because the length of the man is so negligible, right, when compared to the huge length of the train, right? When compared to the length of the train, the length of the man is so small, right? It is going to be something in a fractional part. So you can basically neglect it. Fine. It is not that we are not considering it. It doesn't have any particular value when compared to the huge length of the train. So that's why we are not considering it. So it's without length problem. Fine. So this without length problem, there is a man, he is not having any length. So you tell that the train has passed the man when? If the front and the back of the train has actually crossed the man. Okay. So that is only the speed of the train involved here. The man is not at all moving. He is a stationary body, right? So we know that speed is equal to distance by time. And what do you know right now? This is the length of the train. So what did I tell right now? A train has crossed the man, only the entire length of the train has passed him. So we also know the speed relative into time is equal to distance relative. Alright, so what is the speed relative right now? It is nothing but this man is not moving, he is only going to stay here. So you have to only consider speed of the train. Okay, into time is equal to what is the distance this man has covered? Is the entire length of the train. Alright, so this is the formula when you have a stationary body and only the train is moving, right? So at that time, so this is case 1 scenario you have to consider, and this is the formula for it. So let's consider the case 2 scenario wherein there is a stationary object but with length, alright? So if it's with length, they ask you mostly a platform or this is a bridge, okay, which is of some L, length of the platform suppose. Alright, so in order to cover the length of the platform, what does it mean? The same scenario as that of the man, alright. So for a man, what did I consider? The start of the train and the end of the train was cross this man, okay. So similarly for the platform, the start of the train and the end of the train must cross the entire length of the platform as well. Alright, so this platform is stationary, alright, it's not having any speed. So what is the speed right now? So again the same formula, speed relative into time is equal to distance relative. So what is the speed relative right now? This one is a stationary component. So you have to only consider speed of the train. Alright, into time is equal to what is the distance right now? So distance will be the entire length of the train and the entire length of the platform as well. So L train plus the length of the platform as well. Alright, so that is the only difference. So this is case 2 scenario. Alright, you need not mug up this. It's only enough if you just know this formula, that is speed relative into time is equal to distance relative. So just draw the question. So read out the question, just draw it pictorially, something like this. So as you draw now, you will automatically get this into mind. I don't want you guys to mug up 1 or 2. It's only enough if you just know speed relative into time is equal to distance relative. relative. Look at the question, analyze the question, then from this formula, derive the formula like this. Alright, so let's look at train crossing moving object. Okay, so far we have covered the stationary object part. Right, so let's look at moving object. So let's look at this question. A train crosses a pole in 5 seconds. If the length of the train is 400 meters, find the speed of the train. So, write it, a train is there. Alright? Yes. So, a train is going to cross a stationary pole, alright, in 5 seconds. So, there's only the speed of the train, alright, and this is stationary object. The length of the train is given to be as 400 meter. Find the speed of the train. We know that speed relative into time is equal to distance relative. Alright, so speed relative, this is not moving, stationary. So you have to only consider speed of the train. We have to calculate it. Alright, so that is x. Or let's have the speed of train only. So speed of train, okay, into what is the time taken. The time taken to cross is given to be as 5 seconds. And the distance relative will be what? The distance the pole has to cover is only the length of the train. Okay, and the length of the train is given to be 400 meters. Alright, yes. So, what is the speed of the train? Speed of the train is nothing but 400 divided by 5, which is nothing but 80, which is 80 meter per second. Okay, so that is going to be the speed of the train. 80. So now, let's look at this question. A train crosses a platform of length x in 10 seconds. If the length of the train is 500 meter, the speed of the train is 80 meter per second. Find x. Okay. So first step, always draw it. Alright. So there is a train. Fine. Okay. And have they given the length of the train? The length of the train is given to be as 500 meters. Alright. Yes. Speed of the train is given to be 80 meters per second. And a train crosses a platform. Okay. There is some platform. And I don't know the length of the platform, it's given to be as x. Alright. So, what should we have find out? You should find out x. So, what do we know? Speed relative into time is equal to distance relative. So, this is a stationary object. So, what is only moving? The train is only moving. So, you have to consider only the speed of the train. Alright. So, that is 80 into, have they given t? Yes. It takes 10 seconds. Alright. 10 seconds to complete. So, what is the distance relative now? The distance relative will be the length of the train plus the length of the platform. Yes, we just looked at it, right? So length of the train plus length of the platform. So it is nothing but 500 plus x. Alright, here so far. So it is 800 is equal to 500 plus x. So x is equal to what? 800 minus 500, which will be 300. So the length of the platform will be 300 meters. Alright. I hope it's clear. So let's look at train crossing moving object kind of problems, right? So now let's consider the second case, okay? Train crossing a moving object scenario. So it can again be subcategorized into two, okay? A train crossing a moving object without length, okay? So that is the object has a negligible length when compared to the length of the train. Or second case is a moving object with length, okay? So let's initially start off with without length kind of problems. So it can have two scenarios again, subdivided into two scenarios basically. So suppose that there is a train, alright, fine, yes. And then there is a person right here, it looks like a bus I know, but no, it's a train, okay? So and there's a person here, alright. So if this train is of length some LT, and then it is moving with the speed of s train, fine. This person here is moving towards a train with a speed of some s2, alright. So, how am I supposed to calculate things with this? Okay, let's think practically. What do you know? Speed relative into time is equal to what? The distance relative. Fine, makes sense? Yes. So, what is the speed relative right now? We know that when two components are going to come towards each other in opposite direction, what happens? The speed relative is the summation of those two speeds. So right now it is going to be nothing but the speed of the train plus the speed of the speed 2 into the time taken is equal to what is the distance relative? This distance relative is nothing but the total length, okay? This person has a negligible length, so his length is only consider the length of the train is equal to the length of the train. Okay, so this is the third formula. But that can be another scenario. Okay, there is a train here, fine, with the same length of L train. Okay, and it's moving with the speed of S train. Okay, fine. And there's another person. He actually misses this train. Okay, and so he's going to catch this train. He's running the same direction as the train with the speed of S. So now tell me, how should I calculate this? S relative into time, always like this. Okay. S relative into time is equal to distance relative. So what will be the relative speed when both are in the same direction? We know that it is going to be what? It's going to be the subtraction of those two. So it is the speed of train minus the speed of the man into the time taken is equal to what is the distance he has to cover? He has to cover the entire length of the train only. Okay, is equal to L train. So this is the other formula. Alright, so this is for without length scenario. Alright, I hope it's clear now. So let's look at some sample questions for these two categories, 3 and 4. Right? So let's look at this question. The time taken by a train, 180 meters long, traveling at 42 km per hour, in passing a person walking in the same direction at 6 km per hour will be what? So they have asked you for the time taken. Alright, so let's represent it pictorially. Fine. So there is a train. Alright, that is 180 meters long. Alright. It is traveling at what? It is traveling at speed of 42 km per hour. In passing a person walking in the same direction. So there is another person who is also walking in the same direction at a speed of 6 km per hour. So what will be the time taken is the question. So we already know how to solve this. How do you solve the speed relative into time taken is equal to distance relative. So write down the formula. So what is the speed? There are two speeds given. The speed of the train as well as the speed of the man. So if they are in the same direction, then we are supposed to subtract it. So it is the speed of the train minus the speed of the man. Alright, into the time taken is equal to what? The distance will be the man's length is negligible. So the only length is the length of the train, which is going to be L train. Alright. So now look at the question again. If you notice, all the units are different. This is meter, this is in kilometer per hour, and then look at the options. Okay, so the options is given in seconds. So obviously you have to convert what? Only this kilometer per hour into meter per second. So we already know how to convert this kilometer per hour into meter per second. We have already seen it in the very first module of speed, distance and time chapter, right? So how do you convert kilometer per hour into meter per second? You multiply it. Okay, kilometer per hour to meter per second. How do you do it? You multiply by 5 by 18. So 42 into 5 by 18. That is going to give you what? 21, 9, 21. So 35 by 3. Alright, 35 by 3 meter per second. So this is nothing but 35 by 3 meters per second. And then this 6 km per hour can be written as 6 into 5 by 18. So it is again 5 by 3 meter per second. Alright, makes sense? Fine. So now everything is in meter per second. So what is the speed of the train? 35 by 3 minus what is the speed of the man? 5 by 3 into, we have to calculate the speed, is equal to the length of the train. Length of the train is given as 180 meter. So 35 minus 5 is 30 by 3 into t. So this is nothing but 10 is equal to 180. So time taken is equal to what? 18 seconds is going to be your answer, which is nothing but option A. So that's how you are supposed to find the answers to this question. So you have to only remember this formula. It's not necessary for you to remember any other formula. You have to only know this formula, then draw the diagram for the given question, analyze it, and then fill in the values for speed relative and distance relative. That's how you are supposed to proceed with any question that comes in the train module, right? So let's look at another question. Let's consider the second case, okay? Train crossing moving object where the moving object has some length. Alright? So if you notice now, train crossing a moving object that is going to have some length. So again, this can be subdivided into two categories, alright? So there is a train, alright? that has length of L1 and is going to move with the speed of S1. Alright, and there is another train, alright, that has a length of L2 and is going to move in the opposite direction to the first train with the speed of S2. So now, let's bring a relationship between these two. How do you bring it? Always, what is the formula? Speed relative into time is equal to what? The distance relative. Alright. So what is the speed relative here? This is moving with the speed of S1. The other train is moving with the speed of S2. So they go in the opposite direction. So when it's in opposite direction, then you know it's summation basically. So it is S1 plus S2 into T is equal to what is the distance relative? Both of this have a distance. Right? So it should be what? Distance relative will be L1 plus L2. Alright, makes sense? So this will be equation number 1. Alright. So we get second scenario. So what is the second scenario? Second scenario is a similar situation, but the point is speed S1. And the other train of length L2 is also going to go in the same direction as that of the first train. Alright. So if at all both of the trains are going to go in the same direction, then what is the formula? Speed relative in time is equal to distance relative. So speed relative will be what? S1 minus S2 such that just have the absolute value of this, alright? Because we want it only to be a positive value. Alright, into time is equal to what is the distance relative? The length of both the trains is equal to L1 plus L2. So this shall be an equation number 2. So let's look at a question with these two cases, alright? So let's consider this question. Two trains of length 120 meter 90 meter are running with speed of 80 km per hour and 55 km per hour. How? Towards each other. If they are 90 meters apart, after how many seconds will they cross each other? Is the question. So represent it pictorially. Alright. So you have two trains. Alright. One is of length 120 meters. Alright. Yes. Are running with speed of 80 km per hour, and the other one, alright, is of length 90 meter and is going to run at a speed of 55 km per hour. So if they are, this is 90 meters again. So if they are 90 meters apart, so the two trains, the initial distance between the two trains is given to be as what? 90 meters. Alright, makes sense? So far we never saw a scenario like this. Alright. So after how many seconds will they cross each other is the question. So now what do you know? What is the basic formula? Speed relative into time is equal to what? Distance relative. So what is the speed relative? These two are going in opposite direction. So summation. Summation is 80 plus 55. So it is nothing but 135 km per hour. Which is look around, okay? So this is in kilometer per hour, but all of the other components are in meters. This is in meter, this is in meter, this is in meter. Okay, and the answer is asked in seconds. So I don't want it in kilometer per hour. So convert it into meter per second. So how do I convert it into meter per second? It is nothing but you have to multiply by 5 by 80, right? Yes. So 3 tables. 15. So 18, 6, 15. So it is nothing but 25, 75 by 2, right? Yes. So it is 75 by 2 meters per second. Alright. So distance relative will be equal to what? Okay, speed relative is 75 by 2 meters per second. So the distance relative will be equal to the length of the train 1. So it is 120 plus length of train 2 plus 90 plus what is the distance between them? Okay, they are already 90 meters apart. So for them to cross each other, no, you have to have 120 plus 90 plus 90 again. So it is going to be what? 18, 120 plus 180, which is nothing but equal to 300, right? So this is in meters. Alright. So they have asked you the time taken to cross each other. Time taken will be equal to what? Speed is equal to distance by time. Time is equal to distance relative divided by speed relative. Alright. So what is my distance relative right now? It is 300 meters. divided by, what is the speed related? Is 75 by 2, so it will become as into. Alright, you can cancel it in 5 tables. So 5, 25, 6 5 is 30, 15, 4 is 60, so 4 to 8. So the answer is 8 seconds. So therefore it takes 8 seconds for both of these trains to cross each other. Okay, so this is how you're supposed to do it. Only remember this formula. This is so vital, right? So let's look at one last question. Okay.